In our inspection work, we're looking for four main types of damage: the general condition of the coating, buckling of the steel structure, cracks in plate sections and wells, and corrosion. The coating condition tells us a lot about the general condition of the hull and may act as a guide as to the need for closer inspections. There's usually a connection between stress and tension and the condition of the coating, as such stresses often cause the coating to crack. Until recently, ballast tanks were often not coated or only partly coated in the upper part. With today's reduced scantlings, overall coating is recommended on all new ships. Coating in ballast tanks is to be evaluated every 2.5 years at intermediate and renewal survey for vessels older than 10 years as part of the renewal survey of the hull. The result may be rated as good, fair, or poor, which is done by using photos showing the representative conditions and with reference to the definition as given in the Society's rules. When the coating is rated poor at intermediate and renewal survey, the ballast tank will be subject to an overall survey at the next scheduled annual survey for the purpose of monitoring further deterioration of the tank structure. The same procedure will be applicable for ballast tanks which are not originally coated. An annual survey is required by the Classification Society for all ballast tanks that are found to have a coating in poor condition or no coating at all, but which may be avoided if the tank is recoated. However, in such cases, special preparations are to be followed and the coating is to be of an approved and certified type. Many oil tankers in operation today have often been built with relatively low factors of safety against buckling. Again, this is due to the use of more optimized design with regard to building cost and including the use of high tensile steels. Buckling occurs in areas exposed to compressive stresses and is caused by in-plane forces. Buckling of plates, stiffeners and panels is considered the most susceptible. A distinction is made between local and global buckling. Extensive buckling of the deck or bottom structure may lead to the total collapse of the hull girder and should be given serious attention if found. Cracks are most likely to be found in areas of high tensile stresses, as found at connections and intersections or in openings. These are mainly results of stress concentrations and dynamic loads. Cracks may develop into becoming severe problems for the local structure. They may normally be detected before the whole ship is at risk, but expensive pollution problems may still be the result if the cracks are in the shell plating. High tensile steel is today a common material, used both in double skin and single skin oil tankers. This is due to the cost advantage provided by allowing reduced scantlings and in reduced steel weight. The use of high tensile steel, or HTS for short, in the ship's structure generally means that smaller corrosion margins have been built into the ship, and there is increased risk of cracking and must therefore be given special attention during inspection.